Now, before we go into Euclid's axioms and postulates, it's important for us to look at some of the important definitions. Now, I know that you know all these definitions, but it's important for us to revise such definitions once again. Now, clearly, we know that this represents an angle, but we can say that an angle is the inclination to one another of two straight lines that meet. So we can clearly see that there are two straight lines that meet each other at the point A, but it is actually the inclination of this line to this line. So inclination of one line to another line at the point of intersection is known as the angle between these two straight lines. Now what do we mean by the vertex of an angle? We can say that the point at which two lines meet is called as the vertex of angle. So vertex of angle here is point A, and it is the point at which these two straight lines meet each other. So angle is the inclination of one line to the other, and vertex is the point of intersection of these two straight lines. So the point A here represents the vertex of this angle. Now let's see what do we mean by a right angle. If a straight line that stands on another straight line makes the adjacent angles equal, then each of those angles is called as a right angle, and the straight line that stands on the other line is called as a perpendicular to it. So if we have one line and there's another line standing on this line such that the adjacent angles, here the angles are angle 1 and angle 2, and so if angle 1 is equal to angle 2, then each of these angles is actually a right angle, and this line which stands on this line is known as the perpendicular. So any line which forms an angle of 90 degree with another line is the perpendicular to the other line. Now, an acute angle is less than a right angle, and obtuse angle is greater than a right angle. So if we have an acute angle, then it is obviously less than right angle, and if we have an obtuse angle, then it is greater than the right angle. Let us say that this represents an acute angle, this represents a right angle, and this represents an obtuse angle. Then in this case, we can say that acute angle is less than the right angle, and right angle is less than the obtuse angle. So this inequality holds for every angle. Now, angles are complementary or complements of one another if together they equal a right angle. Angles are supplementary or supplements of one another if together they equal two right angles. If two angles together make a right angle, then these two angles are known as complementary angles. And if two angles together make two right angles, that is 180 degrees, then such angles are called as supplementary angles. So, let us say that this is one angle. Let us say that this angle is angle 1. Similarly, we have another angle, angle 2. And if both these angles make together a right angle, then these angles are complementary angles. That is, angle 1 plus angle 2 is equal to 90 degrees, which is a right angle, and so angle 1 and angle 2 are complementary angles. Similarly, let us say that we have another angle such that this represents angle 1 and this represents angle 2. Now if angle 1 plus angle 2 is equal to 180 degrees, or they make two right angles, then these two angles, angle 1 and angle 2, are supplementary angles. Now, rectilinear figures are figures bounded by straight lines. A triangle is bounded by 3 straight lines, a quadrilateral is bounded by 4 lines, and a polygon by more than 4 straight lines. So we can say that rectilinear figures are figures which are bounded by straight lines. So any figure which is bounded by straight lines is known as a rectilinear figure. Now, this figure is actually a triangle. Why? Because this has been bounded by 3 straight lines, and so it has got 3 sides, and hence it is called as a triangle. Similarly, if we have a figure in which there are 4 sides, or which is bounded by 4 straight lines, then it becomes a quadrilateral. And if we have a figure which has more than 4 sides, or which is bounded by more than 4 straight lines, then it is a polygon. Here in this case, it is bounded by 6 sides, and the name given to such a polygon is hexagon. So this represents triangle, this represents a quadrilateral, and this represents a hexagon bounded by 6 sides. Now what is a square? Square is a quadrilateral in which all the sides are equal and all the angles are right angles. So square is a quadrilateral in which all the 4 sides are equal and all the angles formed are equal to 90 degrees. Now ABCD represents a square in which all the sides are equal to each other and the angles formed are equal to 90 degrees. A regular polygon has equal sides and equal angles. So what is a regular polygon? A regular polygon is a polygon which has got equal sides and all the internal angles formed are equal to each other. For example, this represents a regular polygon. In this polygon, we can see that all the sides are equal to each other and all the internal angles are also equal to each other. The next definition is an equilateral triangle has 3 equal sides. An isosceles triangle has got 2 equal sides and a scalene triangle has got 3 unequal sides. So now when we talk of triangles, there can be 3 cases. Either all the sides are unequal, 2 sides are equal, and all the 3 sides are equal to each other. So if we have a triangle in which all the sides are equal to each other, we say that this side is equal to this side and this side is also equal to this side. That is, all the 3 sides are equal to each other, then this is known as an equilateral triangle. Similarly, if we have a triangle in which these 2 sides are equal to each other and the third side is unequal, then such a triangle is known as isosceles triangle. So this represents an isosceles triangle. And finally, if all the 3 sides of a triangle are unequal, then such a triangle is known as a scalene triangle. So here this represents an equilateral triangle because all the sides are equal to each other. This represents an isosceles triangle because 2 sides are equal to each other and the third side is unequal. And a scalene triangle is one in which all the 3 sides are unequal. The next is figures are congruent when if one of them were placed on the other, they would exactly coincide with each other. So congruent figures are thus equal to one another in all respects. So we can say that 2 figures are congruent if we could exactly place the other figure on the first figure and these 2 figures would coincide with each other. Or the congruent figures are equal to one another in all respects. Let us say that these are the 2 figures. Now if we place this figure over this, then we see that these 2 figures exactly coincide with each other, and so these 2 figures are congruent to each other. Let's take one more example. These are the 2 triangles. Now if we could exactly fit this triangle over this triangle, then these 2 triangles are congruent to each other. Here we see that these 2 triangles are exactly identical to each other. They have the equal sides and they have the equal angles. So these 2 triangles are congruent to each other because they exactly coincide with one another. Now, parallel lines are straight lines that are in the same plane and do not meet, no matter how far extended in either direction. So we can say that if we have a plane and this is the first line and this is the second line, now these 2 lines are parallel to each other because if we extend them infinitely, then they do not meet. So lines which do not meet each other are known as parallel lines. So 2 lines in the same plane and which do not meet with each other or which do not intersect with each other are known as parallel lines. In this case, the blue line and the green line both are parallel lines, both are parallel to each other. Now, the next is a parallelogram is a quadrilateral whose opposite sides are parallel. Now we have just seen what are parallel lines. Parallel lines are lines which do not meet or which do not intersect. Now also parallelogram is a quadrilateral and it is bounded by 4 sides. Now it says that a parallelogram is a quadrilateral whose opposite sides are parallel to each other. So this represents a parallelogram in which these 2 sides, that is the opposite sides, are parallel to each other. That is, this side and this side do not intersect with each other. And similarly, these 2 opposite sides are also parallel to each other. That is, they do not intersect with each other. So parallelogram is a quadrilateral whose opposite sides are parallel to each other. Now what is a circle? Circle is a plane figure bounded by one line called the circumference, such that all the straight lines drawn from a certain point within the figure to the circumference are equal to one another, and that point is called as the center of the circle. So let's try to figure this out. We can say that circle is a figure which is bounded by a straight line, and this straight line is called as the circumference. Now from a point, if we draw straight lines to the circumference, then all these straight lines are equal to one another, and this point is called as the center of the circle. So center of the circle is the point from which all the straight lines drawn to the circumference are equal in length. So circle is a plane figure bounded by one line. This line is known as the circumference. Also, all the straight lines drawn from a certain point within the figure to the circumference are equal to one another. This point is known as the center. A diameter of a circle is a straight line through the center and terminating in both directions on the circumference. A straight line from the center to the circumference is called as a radius, plural radii. Now what is a diameter? Diameter of a circle is a straight line that passes through the center and it terminates in both directions on the circumference. Similarly, a straight line from the center to the circumference is called as a radius. So let us say that this is a circle in which this is the center, and if a line passes through the center and it terminates on the circumference, then this line is known as the diameter. Similarly, if we have a straight line from the center and it terminates at the circumference, then this line is known as the radius. So for any circle, diameter represents a line that passes through the center and it terminates in both directions on the circumference. Similarly, radius is a straight line drawn from the center to the circumference. Now these were some of the definitions which we already know, but to understand the axioms and the postulates, we needed to revise such definitions. So now let's see what do we mean by the axioms and postulates. So now Euclid assumed certain properties which need not to be proved. These assumptions are universal truths. So to derive different theorems and propositions, Euclid assumed certain properties and he didn't prove these properties. These assumptions are universal truths and we don't have to prove these assumptions. Now assumptions could be axioms or they could be postulates. Now assumptions are something that we take it for granted and we do not have to prove the truth of such assumptions. Now also assumptions are of two types, axioms and postulates. Euclid was the one who divided assumptions into axioms and postulates. In a layman language or in a day-to-day life, axioms and postulates take the same meaning. Use them interchangeably. But Euclid differentiated between axioms and postulates. Now how? Let's see. What are postulates? Euclid used the word postulate for the assumptions that were specific to geometry. So Euclid termed all the assumptions that were specifically confined to geometry as postulates. And what were axioms? Common notions, often called as axioms, were assumptions used throughout mathematics and do not specifically linked to geometry. You can say that postulates were assumptions that were used specifically to geometry, but axioms are assumptions that are used throughout mathematics and do not specifically link to geometry. So that's the basic difference between postulates and axioms according to Euclid. Now, so let's try to understand the Euclid's axioms. The first is, things which are equal to the same thing are also equal to one another. So two things which are equal to a same thing are also equal to one another. Let's try to understand this. We have got three figures. Now if the first thing is equal to the second thing and also the third thing is equal to the second thing, then we can say that the first thing and the third thing are also equal to each other. So if first thing is equal to the second thing and if second thing is equal to the third thing, then ultimately the first thing is also equal to the third thing. And this is one of Euclid's axioms. So we can say that if A is equal to C and if B is equal to C, then A is equal to B. The second axiom is, if equals are added to equals, the wholes or the sums will be equal. So if equals are added to equals, then the sums obtained would also be equal to each other. For example, if we have two figures such that the area of these two figures is equal to each other, then if we add equal areas to both these figures, let us say that this is the figure which we have added to this figure, and similarly this is the figure we have added to this figure, and these two figures have equal areas, then we can say that the entire area of this portion is equal to entire area of this portion. Thus we can say that if equals are added to equals, already these two were equal in areas, and we added equal areas to both these equal areas, then the sum obtained is also equal to each other. So we can say that if A is equal to B, then A plus C is equal to B plus C. Let's look at the third axiom, and it says that if equals are subtracted from equals, the remainders will be equal. Now earlier we added equals. Now here if we subtract equals from equals, then again the result obtained or the remainders obtained would also be equal. For example, let us say that this is a figure which is equal to this figure. That is, the area of this figure is equal to this figure. If we subtract equal areas from these two figures, then the results obtained would also be equal to each other. So we have subtracted equal area from both the equal figures, then the remainder obtained or the result obtained would also be equal to each other. So we can say that if A is equal to B, then A minus C would also be equal to B minus C. So if equals are subtracted from equals, the remainders would also be equal. The fourth axiom is, things that coincide with one another are equal to one another. Let us say that these are two figures. Now, if we place this figure over this figure and they exactly coincide with each other, then the two figures are equal to each other. So things that coincide with one another are equal to one another. The fifth is, the whole is greater than the part. Whole portion is always greater than the part of that whole. For example, if we have a circle and if we take out a part from this circle, then we have been left with two parts. Now, initial was this circle. Now we can clearly see that this part is smaller than this part, and also this part is smaller than this part. And these two are the constituent parts of this whole circle. If we see that the whole is greater than individual parts. Things which are double of the same things are equal to one another. So if we have got two things which are double of the same things, then the two things are also equal to each other. For example, if we have this figure and we have a thing that is double of this thing, so this figure is actually the double of this figure. Similarly, if we have a figure which is also double of this figure, then in this case we can clearly say that these two figures are equal to one another. Thus we can state this as, if A is equal to 2C, or A is double of C, and similarly we have B which is also double of C, then actually A and B are equal to each other. Similarly, things which are halves of the same things are equal to one another. So let's try to understand this. Let us say that we have a circle and we have a semicircle over here. This is actually the half of this portion. So this figure is half of this entire circle. Similarly, we have another portion which is exactly the half of this figure. So what we can say is, these two figures are equal to each other. Thus, things which are halves of the same thing are equal to one another. So we can state this as, if A is equal to C by 2 and B is also equal to C by 2, then A is equal to B. These are some of the important axioms used by Euclid. Now, let's turn our attention towards Euclid's 5 postulates. Postulates are the assumptions that are confined specifically to geometry. So let's try to understand the Euclid's 5 postulates. The first postulate is a straight line may be drawn from any one point to any other point. So we can draw a straight line from any point to another point, and this is postulate number 1. Another way of saying this is there is a unique line passing through 2 points. There is a unique line passing through 2 points. So if postulate 1 given by Euclid is a straight line may be drawn from any one point to another point, we can state this postulate in another manner, which is there is a unique line passing through 2 points. If we have got 2 points, then there is a unique line that passes through these 2 points. Let's try to understand this postulate. Let us say that we have got 2 points A and B. So from A we can draw different lines such as this line, this line, this line. Similarly, from point B we can have different lines like this, like this, like this. But a line passing through A and B would be this line. So only this line passes through the points A and B, and thus we can say that only a unique line, or there's only one line that passes through the points A and B. From a single point we can draw infinitely many straight lines, but we can draw a unique line. That is, there's only one straight line that passes through 2 given points. Let's look at postulate number 2. It says that a terminated line can be produced indefinitely in both the directions. So this postulate says that if we have a terminated line or we have a line segment, then we can produce this line segment indefinitely in both the directions. So let us say that we have a terminated line that passes through the points P and Q. So P and Q are the endpoints of this line. Now postulate 2 says that we can extend this line indefinitely in both the directions. So we can extend this line indefinitely in this direction, and also we can extend this line in this direction. So a terminated line can be produced indefinitely in both the directions. Let's look at postulate number 3. Now what does this postulate say? It says that a circle can be drawn with any center and any radius. So it says that a circle can be drawn with any center and any radius. Let us say that we have a center. Now keeping this point as a center, we can have many such circles. Here the radius differs, and so this blue circle, red circle, yellow circle and this black circle can be drawn having the same common center, but the radii differ. Similarly, if we have kept this as a center and radius as r, we can draw this circle. We can keep this as a center, and keeping the radius constant r, we can draw another circle. Again, keeping radius r as the same, we can have a different circle with center as this point, and similarly with this center we can draw a circle with radius as r. Thus we can say that a circle can be drawn with any center and any radius. Postulate 4 is all right angles are equal to one another. This postulate is very simple, and it says that all the right angles are equal to one another. So if we take this as a right angle and this as a right angle, then both these angles are actually right angles, and hence both these angles are equal to one another. So all the right angles are equal to one another, and this is postulate number 4. Let's look at the 5th postulate. So the 5th postulate says that if a straight line that meets 2 other straight lines makes the interior angles on the same side less than 2 right angles, then those 2 straight lines, if extended, will meet on the same side. Postulate number 5 says that if we have a straight line that meets 2 other straight lines, and makes the interior angles on the same side less than two right angles or less than 180 degrees, then these two straight lines, if extended, will meet on the same side. Now this postulate seems to be really complicated, and this is one of the most controversial postulates ever seen in the history of mathematics. Let's first try to understand this postulate. Let us say that we have a straight line PQ. Similarly, we have another straight line MN, and there's a third straight line AB that intersects both these lines P and Q. Now, angle 1 is the interior angle formed by the line PQ and line AB. Similarly, we have another interior angle, angle 2, formed by MN and AB. This is angle 3, which is also an interior angle formed, and this is angle 4, which is also an interior angle formed by line MN and AB. Now, according to this postulate, if angle 1 plus angle 2 is less than 180 degrees, that is, it is less than two right angles, then these two lines PQ and MN would intersect on this side. So, if angle 1 plus angle 2 is less than 180 degrees, then these two lines would intersect along the side of angle 1 and angle 2. So these two lines PQ and MN intersect this side. This side is the side which has angles 1 and angle 2. If angle 1 and angle 2 were greater than 180 degrees, then these two lines would have intersected this side along angle 3 and angle 4. So this is postulate number 5. This postulate is a bit complex postulate when we compare it to the first, second, third and the fourth postulates that we have studied. So we are going to understand this postulate in more detail in our next section. This was all about Euclid's axioms and Euclid's 5 postulates. After Euclid stated his postulates and axioms, he used them to prove other results. By using these results, he proved some more results by applying deductive reasoning. The statements that were proved were called propositions or theorems. So, Euclid first of all stated some of his postulates and axioms, and then he used these axioms and postulates to prove some other results. By using these results, he proved some more results by applying deductive reasoning. So, using the technique of deductive reasoning, he started proving some more results. And these statements that were proved are called as propositions or theorems. Euclid deducted 465 propositions in a logical chain using axioms, postulates, definitions and theorems proved earlier in the chain. So, using the tool of deductive reasoning, he deduced 465 propositions in a logical chain, and this he did using the axioms, postulates, definitions and theorems which he proved earlier in his chain of reasoning. Seen the postulates and the axioms, let's try to solve a few examples. Following figure, the point Z lies between x and y, such that xz is equal to yz. Then, which of the following is correct? Option number A is xz is equal to xy. Option number B is xz equal to 1 by 2 of xy, and xy is equal to 1 by 2 of xz. So in this problem we have been given a following figure in which there's a line and z lies between x and y such that xz is equal to zy, and we have to find out which of the following options is correct. So let's look at the solution of this problem. We have a line xy and we have a point z in between x and y such that xz is equal to zy. So xz is this length and zy is this length. So xz is equal to zy. Now we can also write xy as equal to xz plus zy. So zy is equal to xz. Therefore we can replace zy by xz, and therefore xy would be equal to xz plus xz, and this is nothing but equal to 2 times xz. Thus xy is equal to 2 times xz, and so we can write xz equal to 1 by 2 of xy. So the length of xz is half the length of xy. and this is nothing but option B, and so we can say that option number B is correct. Let's try to solve one more example. If P, Q and R are 3 points on a line and Q lies between P and R, then prove that PQ plus QR is equal to PR. So in this problem we have been given a line and there are 3 points P, Q, R on this line, such that the point Q lies between P and Q. We have to prove that length of PQ plus length of QR is equal to the length of PR. Thus in this problem we have to prove that PQ plus QR is equal to PR. So once again let's look at the solution of this problem. We have the line such that it has got point P, R and Q. Q is between P and R. In the given figure above, PR coincides with PQ plus QR. So PQ plus QR would be equal to PR. So here we see that PR coincides with PQ plus QR. And Euclid's fourth axiom says that things which coincide with one another are equal to one another. And thus from this what we can conclude is PQ plus QR is equal to PR. So using Euclid's axiom number 4, we have proved that PQ plus QR is equal to PR because PR coincides with PQ plus QR, and so if things coincide with each other then they are equal to each other. Thus PR is equal to PQ plus QR. Let's try to solve one more example. Which of the following is a basic axiom of algebra represented by the equation 2x plus 11 equal to 11 plus 2x, where x is any real number? Option number 1 is inverse property of addition. Option number 2 is associative property of addition. Option number 3 is identity property of addition, and option number 4 is commutative property of addition. Problem, we have to find out which is the basic axiom of algebra used by this expression, that is 2x plus 11 is equal to 11 plus 2x, and we have to find out which property of algebra or which basic axiom of algebra is represented by this equation. So given to us is 2x plus 11 equal to 11 plus 2x. So this is actually of the form a plus b is equal to b plus a. Yeah, a is equal to 2x and b is equal to 11. And a plus b equal to b plus a is nothing but the commutative property of addition. We know that. So we can say that option number 4 is correct. Thus the equation 2x plus 11 equal to 11 plus 2x represents the commutative property of addition, and so option number 4 is correct. Let's try to solve one more example, and this is the last problem that we are going to look here. Prove that an equilateral triangle can be constructed on any given line segment. So if we have a line segment, then we have to prove that we can construct an equilateral triangle using this line segment. So once again let's look at the solution of this problem. Let us say that we have a line segment AB. So AB represents a line segment. Now from postulate number 3 we can draw a circle with center A and radius as AB. So we have seen that we can draw any circle with any center and any radius, and this is postulate number 3. So using the postulate 3 we can draw a circle with center A and radius AB. Similarly for center B and radius AB we can again draw a circle. So taking AB as the radius and A as a center, we draw an arc. Similarly taking AB as a radius and B as a center, we can again draw an arc. Now if we join this point of intersection with A, and similarly we join this point of intersection with B. Now let us say that this point of intersection is point C, because this is the radius and we have drawn an arc. Therefore AB would be equal to AC, and similarly AB would be equal to BC. Now also we know that from Euclid's axiom, if two things are equal to a third thing, then the two things are also equal to one another. Thus from Euclid's axiom we get, if two things are equal to a third thing, then the two things are also equal to one another, and thus what we can say that AB is equal to BC equal to CA. Thus in this triangle ABC, we see that AB is equal to BC and which is equal to CA. Thus the three sides are equal to each other. And also we know that if the three sides of a triangle are equal to one another, then such a triangle is an equilateral triangle. So we have drawn an equilateral triangle using a line segment AB. So we have proved that an equilateral triangle can be drawn on any line segment. This was all about Euclid's axioms and his 5 postulates.